Alright guys, so I'm going to make a little video here to help you guys with the lesson today. Um, as with past lessons that we've been doing virtual, I posted on the assignment today the link to, it's called Determining Net Force. I want you guys to read over this whole section yourselves, do any small activities and practice in it. But I'm also going to go over some examples myself. You should watch this video prior to doing the concept builder. Note the directions. You only need to do the apprentice level. It's only 4 questions in the concept builder, and I'm going to complete some of them with you. So if you watch this, hopefully it should be easy to complete. Alright, so recently we've been doing things like recognizing forces acting on objects and then drawing which direction they're in. We're now going to move on to putting a little bit of math to it, not much, because the purpose of all this is to now identify the net or total force in order to possibly find acceleration. So I'm going to go over some examples here. You're going to want to pay close attention to what I do right now because you're going to do the same kind of math in the concept builder. So first of all, the net force, that was a term we had in our vocabulary a little while back when we started all this stuff. Net just means total. Okay? So when we say net force, total force basically means the same thing. And Newton's second law tells us that the net force equals the mass of an object times its acceleration. In other words, not being so mathy, this should make common sense. If you have a net overall total force on a mass, it will accelerate that mass. It'll speed it up or slow it down, or possibly even change its direction. Okay? So I'm going to go over examples kind of like they're done in the concept builder. I'm going to take an object, I'm going to just stamp on the object a mass on it. Let's say we have a 2 kilogram mass. And let's say we have 2 forces pulling to the right. The right's always going to be positive, the left's always going to be negative. Let's say these 2 forces are 6 newtons and 4 newtons. If I ask you to find the net force, it's very simple. In this case, they're pointing in the same positive direction, you just add them. So the net force is just 6 plus 4, which is 10 newtons, positive direction. Then, if I ask you to find acceleration, you'll need to possibly do this on the concept builder. We use this formula and just do some real basic algebra to get A by itself. We divide over the M. So if I want to get A by itself and divide over the M, we get F net over the mass. And if we know F net, which we do because we found it, that's 10, and the mass is stamped on the object right there. 10 divided by 2 is 5, and the units on acceleration are just what they typically are. 5 meters per second squared, like always. So we'll be needing to find either one or both of these things in our concept builder to accomplish it. You'll see in a moment. Let's do a couple more examples. We might have an object that's 3 kilograms, let's say. And let's say we have a 10 Newton force this way and a 3 Newton force this way. Like 2 forces playing tug of war on this object, basically trying to pull it off of each other. Alright, F net. This time we don't add it. Since they're pointing in opposite directions, we subtract. Alright, since 10 is the bigger one, that has a net force of 7 in the positive direction. Pretty simple, I hope, right? And if we want its acceleration, again, we take that net force and simply divide it by the mass. And that's going to be 7 divided by 3. And sometimes they don't come out nice. Use a calculator if you need to. 7 divided by 3. If I round it to 1 or 2 decimal places, that's about 2.3 meters per second squared. Okay? Couple more quick ones. Oops, didn't mean to close that. Let's say we have a similar scenario, but let's say the bigger force is to the left. Let's say we have 8 newtons this way, but 2 newtons this way on a 2 kilogram object. Okay? Now, still, remember your directions. You still subtract them, but since the 8 is, the bigger pole is in the negative direction, my net force is going to be -6. newtons. And then my acceleration, again, is going to be the net force, -6 divided by the mass, which is -3 meters per second squared. One thing that you should notice, and if not, I'll point it out now, the net force direction should always be the direction of your acceleration. So if your net force is negative, your acceleration is going to be negative. If your net force is positive, your acceleration is going to be positive. And if you think about it, that's common sense. If we treat this as like tug of war kind of thing, and the positive person's winning, then you're going to have a positive acceleration, right, in the same direction of that person. Or in this example, if this is like tug of war and the negative person's winning, well, the object, the mass, the 2 kilogram mass, is going to accelerate towards the person with the bigger pull, negative, negative, in other words. And one more quick example, let's say we have a 4 kilogram object, and let's say both forces are this way. Let's say we have 6 newtons and 2 newtons to the left. Those are both negative, because that's the negative direction. This is still the positive direction, so F net is -8 newtons. And if we want the acceleration for the 4th time, we would take -8 divided by the mass 4 and get -2 meters per second squared. So hopefully isn't that hard. And this is what you have to do for our concept builder, which I'm going to go to right now. Let's see. And again, we only are asking you to do the apprentice level. Okay? And we got to pay very close attention to the directions, because some are going to say rank them according to just net force, and some are going to say rank according to acceleration. And that could be 2 different answers if you're not paying attention. I highly suggest you have out some scratch paper so you don't have to keep track of all this in your head. Okay? So what I would do is find out the net force on all 4 of these, and then just rank them, 1 for the most negative, and 4 is a ranking for the most positive, and everything else in between. So let's figure out the net force on all of them. 8 to the left, 2 to the right. That's -6. Okay? This one, 4 to the right, 2 to the left. That's a net force of 2 newtons to the right, or +2. 6 and 4, both in the positive direction, +10. 6 to the left, 2 to the right. That's a net force of 4 newtons to the left, or -4. Don't forget to get your positive and negatives right. Alright, so this one was the most negative. It was -6. I'll put a 1 on that. Then the next negative one was this one. It was -4. I'll put rank 2 on that. The most positive one is this one, leaving ranking 3 there. Check our answers, and we're good. I'll do one more. I'm not going to do this one because it says net force again. I want to do one that says acceleration. I'm going to randomly rank these. I don't care if I get it right or wrong, because I just want to go to the next question. Oh, drats, I missed it. Oh well. Let's get another one. It says net force again. Again, this is just like the one we did, so let's see if I could get an acceleration one here. This thing's being stubborn on me. I'm actually going to view the main menu and return and see if I get an acceleration one. There we go. Okay, so all we got to do, just like in the examples I was doing on the sheet of paper, we still need, if it says a rank according to acceleration, we still need to find a net force. We just divide that net force by the mass and then rank them. Again, a sheet of paper is definitely helpful here. All right, so we got a net force of -8 on this one. And then we divide that by 4. -8 divided by 4 is -2, is the acceleration on this one. We got a net force on this one of -2 to the left. -2 divided by 0.5 is -4. Use a calculator if you have to. We got this one. We have +8 is the net force. +8 divided by 0.25 is going to be +32 meters per second squared. And then finally, the net force on this one, 6 to the right, 4 to the left, that's 2. 2 divided by 0.5 is +4. Alright, so again, the rankings are 1 for the most negative. If we wrote them down, we see that this one was -4 meters per second squared. This one was also negative. The most positive was this one. And the next most positive is that one. Check our answers. We should be good. The main thing is, guys, you got to be very careful that you rank them according to what it says here. All right? If you only rank according to net force and didn't do the division for acceleration, the division of the mass, then you could be wrong. So make sure you pay attention which one you got to do. If it says acceleration, we got to divide by the mass. If it says just net force, we just find that only and rank. Hope that helps, and please complete this by its due date.